We are going to explain the Cypetherm Eplus tool. This training material is part of the European BIM-SPEED project. Cypetherm Eplus is a tool for the analysis and thermal simulation of BIM models. It is based on the Energy Plus calculation engine and can generate detailed reports on a building's energy performance, its enclosures, its thermal zones, and its building systems throughout the year, based on the climatic data of its location. Cypetherm Eplus can be used for the following scenarios: energy simulation of BIM models, and automatic generation of reports containing the building's detailed energy balance. The tool can be used by architects and engineers who need to perform thermal simulations of a BIM model to evaluate its energy's loss and gain behaviours throughout the year. In the video, we will explain the following topics: importing existing BIM models, hosting and transmitting of data through the cloud, energy simulation of BIM models, automatic generating of reports containing the results, exporting data to the cloud, which will then be imported to other applications.
The Cypetherm Eplus application, developed by Cype, is used for modelling and performing energy simulations of BIM models using Energy Plus. This application is integrated into the OpenBIM workflow via the BIM Server Center platform. The first step to follow in order to conduct an energy analysis, or a BEM, a building energy model, is reading an architectural model where its spaces and limits are defined. This model may come from modelling tools such as Cype Architecture, IFC Builder, Revit, Archicad, Allplan, etc., and must be exported in IFC format and linked with a project on BIM Server Center. The next step is importing the generated model to the free tool OpenBIM Analytical Model. This step is not essential, but it is recommended. This application can import any BIM model in IFC format and convert it into a precise geometric model for acoustic and energy analyses. If we do not use OpenBIM Analytical Model, the BIM Server Center model will not have the required information to perform a precise thermal analysis. This step is not essential either. Adding the construction systems information via the free application OpenBIM Construction Systems. This lets users decouple material allocation and energy analysis, allowing them to use this information in other applications and speed up the development of various disciplines of the project. We can start a new project by clicking New. This opens up the BIM Server Center Assistant and allows us to link it to an existing BIM Server Center project or create a new one. Cypetherm Eplus will generate an energy model using an existing BIM model, which generally links us to a previous project. Next, we choose the BIM Server Center model that we are going to import. If we have generated a model with OpenBIM Analytical Model, we must select it. Cypetherm shows a preview of the selected model and the import options. The default options are usually correct. Furthermore, it is important to select all BIM Server project models that are relevant for the thermal analysis. We can also select a directory if we have a library of previously generated materials. If we have used OpenBIM Construction Systems in the project, this will not be necessary. Lastly, the Cypetherm Eplus project opens with all the imported entities. The next step is to define the general settings. In General Parameters, we can configure the general project settings. Specifically, we can toggle the option to calculate surface or interstitial condensation, define the permeability properties of the construction elements of the building, and manually define the hot water demand of the project. We have the option to automatically define the demand, depending on the location of the building. In the location data, we can specify the exact location of the project and manually enter climate data, or import an EPW file of the area. In energy sources, the amount of renewable energy consumed by the building and the conversion factors of the different energy sources are determined. Now we establish all the elements of the building that do not yet have an energy definition. This will not be necessary in the case of having used external libraries or applications such as open BIM construction systems. Each type of element has a specific menu. We will see some of them next. In spaces, a list of all the types of spaces present in the model appears. There are two types, habitable and non-habitable. Spaces that are not one of these types will not be taken into account in the thermal analysis. In the list, we describe the energy properties of the space, including data for ventilation, lighting, people, and equipment. The more data we enter, the more precise the Cypetherm analysis will be. If we do not have all the information, we can use the automatic assistant by clicking on the blue arrow. It will allow us to automatically enter data according to the ASHRAE code criteria. For example, ventilation data can be entered automatically depending on the use of the building. It is also possible to enter even more precise data. For example, we can define the building's daily and monthly occupancy percentages. These percentages can be described graphically and saved in an external library and can be reused in other projects. All this data can also be saved in external libraries, meaning that we only have to define the elements the first time. In subsequent projects, they can be imported and they will be automatically allocated according to the name. For example, if we create a type of habitable space assigned to the type kitchen, we can import it in subsequent projects so that all kitchens are defined automatically. This library management works analogously with all the definable elements in Cypetherm. Defining building elements is somewhat different to defining spaces. All layers of all the project building systems and their thermal properties must be defined. Although each menu is different, pre-configured libraries with thermal data on real materials can be used in all of them. As well as using the library materials, it is also possible to create customized materials with laboratory data. For analyses that do not require so much detail, there is the possibility of defining complex systems in a simpler manner by entering global data representative of the system. As well as a large number of material libraries, Cypetherm also has real construction systems from some manufacturers, including all the materials and their thermal properties. Cypetherm allows us to define each spatial edge for a more precise analysis. This will not be necessary if the model has been put through Open BIM Analytical Model. Cypetherm includes libraries that facilitate the thermal definition of these edges. Once all the materials are defined, we must do the same for the thermal zones. This will not be necessary if the model comes from Open BIM Analytical Model. New zones can be created in the right-click menu. For each zone we specify a name, comfortable conditions, daily hot water demand, and condensation properties. In each thermal zone we can define active air conditioning installations. The program includes numerous configurable types according to previewed and existing units in the BIM project. Similarly, it is also necessary to define the hot water production system and the air conditioning system present in the building. The Floor Plans tab allows us to check that everything that has been defined is in order. In the Analysis tab, we can establish the parameters by clicking Calculation options. Consumption can be included, partitions can be simplified to speed up the analysis, and specific simulation periods can be established, among other things. The analysis can be initiated by clicking Analyze. Once the analysis is complete, we access the general and detailed results, including the Energy Plus file generated and a supporting document regarding energy demand and consumption, among other things. The Export option allows us to export these results to BIM Server Center, so that collaborators have access to them and can use them in other Open BIM applications connected to the platform. Cypetherm is a tool which is integrated into the Open BIM workflow. Therefore, any change that is made in the base model through which we have generated the energy model will update automatically. If the BIM Server Center update button starts to flash, it's because Cypetherm detects a modification. Upon clicking it, an assistant opens where we can select the changes to apply to the model. All thermal data entered into Cypetherm will be maintained, and analyzing the project again will suffice.
Thank you for your attention.